हेलो। हेलो। Is anyone here? Yeah, good evening, Jahid. So yeah, I hope you are doing well. लेकिन मैं नहीं गड़बड़ कर रहा 2-3 दिन से। ठीक है, फाइन. So this is the class on shear strength. We are starting the shear strength chapter. I need this class and tomorrow's class. Tomorrow class, I'll be winding up this complete shear strength, and then we'll see the previous year questions on shear strength. That's it. The course is done. Katham. Hai na? So I need around today, tomorrow, maybe 2 more hours for previous year questions. Fine. Yeah. Okay, fine. We'll start. So yesterday we were discussing about the direct shear test and triaxial shear test, right? So we said that in the triaxial shear test, you have 2 stages of loading, you know. So in the first stage, पहले ये बताना वॉइस क्लियर है जाहिद? अभी वॉइस में कुछ इश्यू आ रहा है? Yeah. Thank you, Jahid. Okay, fine. Yeah. So yes, we'll just give a recap about the previous class, and then we'll move to the CU and CD test. So yesterday we discussed about direct shear test and triaxial shear test, right? So direct shear में क्या होता है कि so we do only biaxial loading, you know. So what we do in the direct, I'll take another page and I'll give a recap. So in the direct shear, what we do is you apply 2 kinds of stresses. First, we'll apply normal stress, and then we apply shear stress. So if the normal stress is more, if the stress is more, then the shear stress takes more, right? That's how we do direct shear test. But in the triaxial shear test, what we do, so in the triaxial shear test, what we do, so initially you apply stress in all the directions, right? Which we call as confining stress. So this is same in all the directions. Cylindrical specimen है ना? So triaxial cell में हम लोग पहले stress देते हैं, that is sigma c, so which is same in all the directions. And then उसका बाद so we'll give additional stress in the vertical direction, which is sigma d. So which is sigma d. So इसको कहते हैं हम deviating stress. Sigma c is cell pressure. Some people call cell pressure, some people call it as confining pressure. Both are same. C for cell pressure or confining pressure, and the sigma d for deviating stress. That is the additional stress. So if you draw more circle for the failure of this, so this your sigma c was here initially, loading was here, sigma c, but this sigma c itself is your sigma 3 and sigma 1 in the starting. But while you are applying this additional load in the axial direction, the more circle shifts like this, something like this, you know, more circle will be shifting something like this. So the sigma d keep on increasing, the vertical stress keep on increasing. At some point, this more circle touches with the failure envelope. So at that case, the failure will be happens. So the soil will get failed. So that is what we call sigma d. That is the additional stress. यही बताया था हम लोग कल का क्लास में. And we said one more thing is that the test is consists of 3 kinds, right? According to the drainage conditions, we have 3 kinds of tests. So क्या है? So you have UU test, you have CU test, you have CD test. एक क्वेश्चन पूछा गया था, सर why not UD? Why not UD? मतलब क्या है? UD का मतलब ये कि सो पहले स्टेज में ड्रेनेज नहीं दे रहे, सेकेंड स्टेज में ड्रेनेज दे रहे, राइट. सो वी आर नॉट, so drainage is not allowed in the first stage. इसका मतलब यू मतलब drainage is not allowed in the first stage, but the drainage is allowed in the second stage. ये इसका सिग्निफिकेंस नहीं, इसका कुछ मतलब नहीं, क्योंकि सी देखो हमारा फेल्यूर कैसे होता है, शेयर फेल्यूर. जब तक इधर सॉइल ले लेते तो बिफोर कंस्ट्रक्टिंग एनीथिंग ये तो कंसोलिडेशन हो चुके हैं ना, कंसोलिडेशन हो रखा है, राइट. सो दिस इज ऑलरेडी कंसोलिडेटेड. Now you are giving the load. Now your additional stress is increasing. That is sigma d. So this is sigma d is increasing, because of which the shear is happening. अभी इस टेस्ट में ये UD मतलब क्या, हम ये बोल रहे हैं कि so we are saying this thing is that पहले पानी बाहर नहीं जा रहा है, लेकिन लोड देने के बाद पानी बाहर चले जा रहा है. So this is what we are saying. This is what we are saying. So which doesn't mean that, which doesn't make any sense, because सालों से सॉइल इधर है, वो कंसोलेशन नहीं हो रहा है, पानी बाहर नहीं जा रहा है, तो हम लोग कंस्ट्रक्ट करते हैं 1 साल में. So in that 1 year, how the water will escape? Not possible, right? So it is not possible. So that's why this is not significant. So we have only 3 types of tests, right? So 2 stages में हमको 2 choices मिलता है, 2 into 2 4 चांसेस होते हैं, लेकिन ये चांस एलिमिनेट हो जा रहा है. सो यूयू टेस्ट में क्या आती है कि स्टेज 1 और स्टेज 2 दोनों स्टेजेस में अनड्रेन्ड होता है, और सीयू टेस्ट में सो विल ड्रेन इन द फर्स्ट स्टेज बट विल क्लोज द वाल्व इन द सेकेंड स्टेज. सीडी टेस्ट में दोनों केसेस में ड्रेन्ड है. सो दिस इज फॉर हाईली परमिएबल सॉइल. So CD is for highly permeable soil like gravelly soils and sands. UU test is for generally clays, you know. So UU test is for generally clays, क्योंकि किले का permeability बहुत कम होता तो पानी बाहर जाने नहीं पाता. So water most of the time cannot escape. So that's why we do UU test, right? So UU test means you simulate the same kind of behavior of a soil in the field in the laboratory. हम लोग क्लोज ही कर देते, वॉल क्लोज कर लेते तो पानी बाहर नहीं जाएगा. सो दैट इज व्हाट द यूयू टेस्ट, दैट इज व्हाट वी सेड. सो द ड्रेनेज इज नॉट अलाउड इन बोथ द स्टेजेस. फर्स्ट स्टेज विच इज कंसोलेशन स्टेज, उसमें भी पानी बाहर नहीं जाने देते, शेयर स्टेज में भी जाने नहीं देते, राइट. सो दैट्स व्हाट वी सेड. बिकॉज द वाटर इज नॉट मूविंग एनीवेयर, तो इधर हम लोग लोड दे रहे हैं. इन द फर्स्ट स्टेज वी आर गिविंग confining stress. In the second stage, we are giving deviating stress. In both the stages, effective stress is not increasing anything. You know, हम लोग consolidation chapter में एक good evening रोशनी, good evening. You guys came, okay, fine. So consolidation में ये क्या बोला था हम पहले? So while you are discussing consolidation chapter, what we said is like while you are giving the load, तुरंत पानी नहीं जाते, यही बोला था ना. सो while you are giving the load, the water is not escaping at the moment. It takes some time for the water to escape. That too, soil has to have permeability, है ना. तो इधर बात ये कि दोनों स्टेजेस में पानी जा नहीं रहे. सो दोनों स्टेजेस में पानी जा नहीं रहे, तो whatever the load that you are giving, even in the first stage which is sigma C, in the second stage you are giving sigma D, all the stresses are converted into pore water pressure, है ना. That is what we said, right? So whatever the load that you give, that will be initially pore water pressure. When you allow the water to go out, pore water pressure कम होता जाएगा, effective stress increase होता जाएगा. लेकिन इधर pore water बाहर ही नहीं जा रहे, तो जितना भी लोड हम दे रहे हैं, that is remains as a pore water pressure. So the effective stress is not changing, right? So the strength also will not change. That is the reason why you observe what? So your deviating stress for all the confining pressures is same. Basically क्या करते हैं हम triaxial shear test में? So what we do in the triaxial shear test is, so you test at least 3 samples, right? You take 1 sample, you give confining pressure of sigma 1. So you give confining pressure of sigma 1. I mean sigma C1, this is confining pressure. उसका बाद हम लोग वर्टिकल लोड देना शुरू करते हैं, राइट? So at some point of vertical load, it fails. Let's say that is sigma d1, right? Yes, first soil sample हो गया. और same ऐसे ही, so the same way you take one more sample and you test it under different confining pressure. So you test it under different confining pressure, which is sigma c2. So ये soil अलग soil sample ले लेते हैं, उसको test करते हैं sigma c2 पे, and you apply again the additional vertical load here. तो ये फर्स्ट स्टेज होने के बाद, लोड अप्लाई करने के बाद, सेल्फ प्रेशर अप्लाई करने के बाद, इधर हम लोग एडिशनल स्ट्रेस दे रहे हैं, दैट this stress will keep on increasing. At some point this will reach failure, and we note down the failure case, that is sigma d2, right? So same way sigma c3 apply करेंगे confining stress, you add on vertical load and the soil will fail at a sigma d3, right? लेकिन इधर क्या कि यूयू टेस्ट होता तो, so the sigma d1, sigma d2, sigma 3 all are same. This is representing the shear strength. Shear strength is same. That is what the observed here, you know. So the sigma d मतलब क्या है? This is the additional stress increase, right? In the first case, that means the diameter of the Mohr circle. Diameter of the Mohr circle. This is sigma d1. So the diameter of Mohr circle is same for all the three cases, you know. So this is the first case, Mohr circle for the first case. So we started at this point, sigma c. Now you keep on adding the vertical stress. So your major principal stress will keep on increasing. So your Mohr circle shifts like this. So Mohr circles move on, shifts like this, and it will reach this condition at the failure. At failure, your Mohr circle, this is the Mohr circle at the failure condition for the first sample, when sigma c1 is the confining pressure. Now this is the Mohr circle for the second sample, where sigma c2 is the confining pressure. This is the Mohr circle for the third sample, which is where the sigma c is the confining pressure. So here confining pressure to बढ़ा रहा है हम, so we are increasing the confining pressure, but the shear strength is not increasing. The diameter of the Mohr circle is not increasing, you know, because कुछ improvement हुआ नहीं soil पे. Improvement कब होगा? जब effective stress develop होगा, soil का अंदर effective stress develop होगा, तब strength पे improvement आएगा. लेकिन इधर effective stress बढ़ नहीं रहा है ना, because undrained, पानी बाहर नहीं जा रहे तो effective stress बढ़ नहीं रहे तो strength increase नहीं हो रहा. So that is the reason why the shear strength is same whatever the confining pressure. So your failure envelope, which is common tangent to all these Mohr circles, will be horizontal, है ना? So that is why in clays mostly where the water is not escaping, so we define shear strength as only Cu. Phi value 0 kar lete. This is a pure cohesive soil. This is a pure cohesive soil. That is what it means, you know. So this intercept is Cu, and the slope of this line is phi, which is 0 because it's horizontal in case of UU test. In case of UU test, this is horizontal, right? So mostly in undrained case, you will get Cu and phi u, but phi u is generally close to 0, right? If the drainage is very, very slow or negligible, right? That is the condition here. Now I want the effective stress parameters. See, this is the total stresses, right? These are the total stresses which I'm giving, right? But these are not the effective stresses, because whatever the load that I'm giving here, that is converted into pore water pressure. So if I want to, so according to the Terzaghi, हम लोग पहले shear strength Coulomb's equation modify कर रखा था, तब क्या बोला था हम? So the shear strength is equals to C dash plus sigma dash into tan phi. This is what we said, right? So this is what we said. This is the equation for shear strength. But the sigma dash, we are not considering sigma dash. These are all the total stresses only. लेकिन मुझे सिग्मा effective stress चाहिए, तो what I'll do? So to get the effective stress, what I do? I'll subtract pore water pressure from the total stress. So I'll subtract pore water pressure from the total stress. मेरा total stress मुझे पता है, इतना दे रहा हूँ मैं, right? So इतना दे रहा हूँ मैं, इतना दे रहा हूँ मैं, horizontal direction में इतना दे रहा हूँ, vertical direction में इतना दे रहा हूँ, sigma c plus sigma d1, right? Now this total stress or whatever I'm giving, that is all converted into that is all converted into pore water pressure. I mean, pore water pressure only. So this, the whole thing is converted into pore water pressure only, you know. So this delta sigma, whatever the additional stress that we are giving, that is converted into pore water pressure only. If delta sigma, total stress change, is equals to pore water pressure change, then the effective stress is 0, right? That's what it is means. And now the point is, so sigma C1 से sigma C2 से जितना भी load increase कर रहे हम, that is all pore water pressure. Now if you subtract pore water pressure from sigma C1, you will get sigma dash C1. That is the effective stress. The sigma C1 is the total stress. You will get sigma dash C1. And the sigma C1 plus sigma D1, which is the major principal stress in first sample failure, that will be converted into the whole thing minus delta sigma. That is delta U, pore water pressure change. लेकिन बात ये कि फर्स्ट केस में पोर वाटर प्रेशर चेंज इतना है, सेकंड केस में पोर वाटर प्रेशर चेंज इतना है. सो जो भी लोड दे रहे हैं, that is all pore water pressure only. Now the point is, for all these cases, all these failure conditions, you will get only one effective Mohr circle. So if you draw the Mohr circle in terms of effective stresses and the shear stress, so you'll get only one Mohr circle. But the one Mohr circle I cannot be utilized in any way, right? So to draw the envelope, failure envelope, or to find out C and phi parameters, so मुझे C and phi, C dash and phi dash पता करना है ना, उसके लिए so for that thing, so this at least two values, two equations I need, right? So at least two shear stresses and two normal stresses I need at the failure condition. I don't get from this one Mohr circle. I need two or more Mohr circles, so which is not possible. So that's why we don't find out the pore water pressure in the UU test. हम कर सकते हैं pore water pressure measurement, लेकिन करेंगे नहीं क्योंकि जरूरत नहीं उससे हम लोग कुछ. So that's not giving you any kind of benefit even you find out pore water pressure. That is the reason why we don't find out the pore water pressure in UU test. ये हुआ बात UU का, unconsolidated, undrained. So this is done when mostly in the clays because permeability is less and loading is very fast. हम लोड दे रहे हैं very fast. उतना टाइम में लोड देने टाइम में पानी बाहर नहीं जा पाएगा. So in that cases we do, for that conditions in the field we do use UU test in the laboratory. उसको simulate करने के लिए वो सेम चीज लैबोरेटरी में क्रिएट करने के लिए हम UU टेस्ट करते हैं. फाइन. सो दैट इज UU टेस्ट. नाउ स्विचिंग इनटू द CU टेस्ट. सो इधर फर्स्ट स्टेज में वी अलाउ द ड्रेनेज. सो व्हाइल यू आर डूइंग कंसोलिडेशन, सो इस स्टेज में यू कीप द वाल्व ओपन, बट इन द सेकंड स्टेज you keep the valve closed. So you keep the valve closed. So in the second stage you keep the valve closed. So first stage you will allow the valve open, so the water will go out. So you give 24 hours for the soil to consolidate, पानी बाहर जाने के लिए. तो जितना भी हम लोग additional stress दिया था, that will all converted into effective stress. In the first stage. लेकिन second stage में हम लोग close कर रहे हैं, valve close कर रहे हैं. So the sigma D, that is pore water pressure again. But the sigma C1 that we are giving, that is effective stress. So that's the difference here, right? That is the difference here, right? So that is the difference here. Now coming to the failure, how this failure happens and how the Mohr circles will develop for this condition, we can see here, right? So this depends on two kinds of soils. We are right now we are looking into the clays, and then we'll explain about the sands also. So this is a clay, right? So these are the test results. If your soil is a kind of normally consolidated, this is a one Mohr circle for one failure, and this is the other Mohr circle for next confining stress, and this is another Mohr circle for the other confining stress. अच्छा ठीक है, मैं अभी और एक figure I'll explain here. So the thing is, so this is my sample, first sample. I'm applying sigma C1, and consolidation happens. So the sigma C1 has to be kept for 24 hours as we told, right? उसका बाद हम लोग deviated stress apply करते. So उसका बाद after that we'll apply deviated stress. So this deviated stress is what we call shearing, right? So this is sigma D1. So the same way you will get sigma C2 for the next sample. So sigma D2 will be more. Sigma C2 is more, so sigma D2 will be more. Okay. लिख लेता हूँ क्यों lazy हूँ मैं. So I'll draw explain that sample too. So this is the second sample where you applied sigma C2. As the confining pressure, that is all-round pressure, cell pressure. इसको कहते हैं हम cell pressure. So in this case, you applied sigma C2 and then you start shearing. So you start applying vertical load. So you start applying vertical load. So vertical load apply करने के बाद failure हो रहा है at sigma D2, at sigma D2. Fine. So the same way you, okay, ये दोनों ही ले लेते हैं. कार्ड सैंपल का जरूरत नहीं एक्सप्लेन करने के लिए. So the thing is, this is the Mohr circle which is representing the first failure case. So this is sigma C1, this point is sigma C1. And the vertical stress, this is sigma C1 is the horizontal stress, which is minor principal stress. Vertical stress is sigma C1, यहाँ से यहाँ तक sigma C1 था, or additional stress that we are giving is sigma D1. So this additional stress that we are giving is sigma D1. So this is sigma D1. Fine. So this is sigma D1. ये तो first sample का. So the Mohr circle representing the first shear failure of first sample is this, right? And the Mohr circle representing the second sample, this sample, is this. Now my sigma C2 is different. Now my sigma C2 is different. This is the point which is representing my sigma C2, cell pressure. ज़्यादा है ना sigma C1 से. That's why it is on the right side. Now here what you observe is the sigma D2 will also be more than sigma D1, you know. So that is why this Mohr circle, second Mohr circle is bigger than the first Mohr circle, you know. So which is not observed in the UU test. UU test में हमको सारे Mohr circles एक ही जैसे दिख रहे हैं ना, same diameter. All the Mohr circles are same diameter. But here the Mohr circles are different diameters. Why? Because हम लोग क्या किया था इधर फर्स्ट स्टेज में. So you allow the water to go out. पानी जा रहा है तो क्या हो रहा है? Consolidation तो हो रहा है ना. So the soil gets stiffened. Soil gets stiff. So as the soil gets stiff, the strength of the soil gets increased. So that's why it is taking more load. That is why it is taking more load. You know, इतना तक load ले रहा था पहले first sample में. Now the load taken by the soil in the second sample is this much. If you increase sigma 3, then it will take more load again, right? So these are the three Mohr circles that we'll get for the three samples. Now if you connect a common tangent to these three Mohr circles, that is the failure envelope. So that is the failure envelope, right? So this is the failure envelope. So it is passing through generally origin if the soil is normally consolidated, you know. So if the soil is normally consolidated clay, so this will pass through origin. Because normally consolidated में क्या होता है कि इसका past stress नहीं है, past में कुछ additional stress नहीं दिया गया था, right? So that means the particles which are in contact, they are not bonded chemically, you know, that much. So that's why the cohesion will be observed 0 in case of normally consolidated clays. Normally consolidated clays. So ये statement में मैं लिख लेता हूँ. So the point is normally consolidated clays, NC clays, C value is 0, equals to 0, you know. So C value equals to 0. That is the point. But what about the over consolidated clays? What about the over consolidated clays? Over consolidated clays. Over consolidated clays का मतलब क्या है? So this is what we explained in the consolidation chapter. बात ये कि देखो दो सॉइल्स में ले रहा हूं इधर. So this is the soil 1 और एक soil है. There was a big structure which was demolished. मैं इधर soil ले रहा हूं, right? So the sigma C, that is the अच्छा अच्छा, प्री कंसोलिडेशन प्रेशर सिग्मा p रिप्रेजेंट करते. So which we have discussed in the consolidation, maximum stress it is experienced in the past, you know, maximum stress it is experienced in the past, right? So that is this much, that is this much, fine. So now you are applying stress in the field, so that is sigma c1. If your sigma c1 is more than the sigma p, वो क्या होगा, वो क्या होगा, नॉर्मली कंसोलिडेटेड हो जाएगा, क्योंकि सिग्मा v1 नहीं उसका पास्ट हो जाएगा, राइट, विच इज मोर. तो सिग्मा c1 itself is the maximum principal stress in the past, so नॉर्मल कंसोलिडेटेड हो जाएगा. लेकिन हम लोग बहुत कम स्ट्रेस अप्लाई कर रहे तो, so when the sigma c confining pressure is very less than the pre-consolidation pressure, then the soil behaves as an over consolidated clay. That is why this is up to this point. See, this represents the pre-consolidation pressure. This point represents the pre-consolidation pressure. ठीक है. अभी हम लोग टेस्ट करने वक्त, while we are doing the testing, if you give lesser confining stress, अभी ये sigma c है, if this is lesser than that sigma p, तो ये over consolidated soil हो जाएगा. ये sigma c वैल्यू है, if it is more than sigma p, then वो normal consolidated soil हो जाएगा. So then that is normally consolidated soil. So this is the normally consolidated soil. At a higher confining stresses, soil behaves as a normally consolidated. So C value is 0. But if you are doing the test for over consolidated soils, right? So the soil failure envelope will be observed something like this, you know. So failure envelope will be observed something like this. Either CU milta hai. So you have CU for over consolidated soils. Because it was already consolidated, the bond was already created. Now you are stressing the soil at a lesser stress. So the particles will already have some chemical bonding, affinity of interaction, affinity of attraction, you know. So that is why the CU will be developed. The CU will be developed, right? So this failure envelope will be something looks like this. So failure envelope will be something looks like this for over consolidated clays, right? So at smaller stresses, this behaves as an over consolidated clay. And when your stress is increasing, when you are increasing the confining pressure beyond the pre-consolidation pressure, uska baad this behaves as a normally consolidated clay. So then the failure envelope will be something looks like this, right? So this is the failure envelope for over consolidated clay. This is the failure envelope for normally consolidated clay. इधर over consolidated clay के लिए CU, this is the CU, and the slope of this curve gives you what? Friction angle, angle of internal friction. This is what we give phi u, right? So this is phi u for over consolidated clay. This slope is generally lesser than this slope, you know. So that's why for over consolidated clay, friction angle will be little bit lesser. Friction angle will be little bit lesser than normally consolidated clay. But cohesion will be developed in over consolidated clay, but cohesion will be 0 in normally consolidated clay, right? So this is the explanation of shear strength in two kinds of soils, which is over consolidated and normally consolidated. ये तो shear strength का behavior है. Now if you observe the testing results, you know, results में हम लोग क्या मिलते हैं? So we observe the stress and strain, isn't it? So if you take axial stress, which we are giving as sigma d, हम लोग इधर axial stress दे रहे हैं ना, sigma d. So if you plot sigma d against the vertical deformation, इधर test करने वक्त क्या करते हैं हम? We keep one dial gauge to measure the vertical deformation. जब हम लोग लोड दे रहे हैं तो soil का वॉल्यूम कम होता जाएगा, है ना? I mean, the height will get reduced, deformation will be measured. So now if you draw the deformation against here, इधर भी दो तरीका, both the over consolidated soils and normally consolidated soils will behave differently, you know. This is the axial stress, which is sigma d, and here we have axial strain. So the curve will something looks like this. The curve will something looks like this for over consolidated soils. So the curve will be something looks like this, you know. So the shear strength will be much higher at the lower strains, you know. But beyond some strain, so what happens, this whole thing will get the shear strength will keep on dropping, right? So this is happening because of the dilation. We'll explain this dilation few moments after, right? So dilation means because it's a clay, so generally the dilation will not happen, but the equivalent of dilation is the negative pore water pressure, you know. So pore water pressure will get negative. So that's why this is all of a sudden this happens in this way, you know. But if your soil is, this is for normally consolidated soils, over consolidated soils, OC clays. But if your soil is normally consolidated, then the failure will be following this way, you know. So the failure will follow in this way. So at larger strains, both the shear stresses will reach same, you know. So both the shear stresses will reach same value. Both the shear stresses will reach same value. इसको कहते हैं हम. So this is the ultimate shear stress, or we say residual shear strength. Residual shear strength. उसका मतलब ये कि ये stress reach होने के बाद soil fail हो गया, right? So this is what we call peak shear strength. So this peak shear strength is observed only in OC clays. This is tau peak, right? So this curve represents NC clay, you know. So because it's a CU test, right? CU test. So in the second stage, you are not allowing the water to go out. So you are not allowing the water to go out. So what? क्या होगा? Pore water pressure develop होगा. So if you observe the pore water pressure variation with the strain. So same pore water pressure variation with the strain. So the pore water pressure variation will be something looks like this, you know. So the pore water pressure variation will be something looks like this. So this is for OC clays, and for normally consolidated clays, NC clays, this is the curve. So this is for NC, and this is for OC, or consolidated. So इधर तक हमारा पोर वाटर प्रेशर डेवलप हो ही जा रहा है, right? हो ही जा रहा है. So the strength is getting increased, but beyond this part, the pore water pressure is negative. Okay, this is positive axis and this is negative axis. मैं थोड़ा reverse कर लिया था. Okay, we will change this. So if you take this as positive, then the curve will be reverse. Okay, change kar lete, because most of the textbooks, this is how it is represented, right? So I shouldn't make you any confusion. So initially the pore water pressure increase in OC clays, and then the pore water pressure will keep on reducing. The negative pore water pressure will be developing, you know. So this is the negative pore water pressure which is developed in the OC clays. But in case of normal consolidated clays, pore water pressure will keep on increasing. This is the normally consolidated clays. So this is so this is over consolidated clays. Fine. So this is normally consolidated clays. ये समझ में आ गया? See, the point is हम लोग ड्रेनेज अलो करता तो if in over consolidated clay, इधर हम लोग ड्रेनेज अलो करता तो while applying sigma d, if you are allowing the drainage, then what happens? The volume will increase, you know, not decrease, because it was already consolidated, over consolidated. There is no scope for the further rearrangement of the particles. तो क्या होगा? अभी shear stress दे रहे तो, so instead of going into the denser state, it will kind of show volume increase, you know. So volume increase, but लेकिन इधर volume हम लोग change करने नहीं दे रहे, right? तो क्या होगा, बाहर से पानी इसको अंदर आ जाएगा. सो दैट्स व्हाई द नेगेटिव प्रेशर, पोर वाटर प्रेशर इज गेटिंग, I mean negative pore water pressure is getting developed in OC clays, because the tendency is to increase volume, so which is not happening, so the pore water pressure becomes negative, right? इसी के बारे में क्वेश्चन पूछा गया था last year, right? So you have a question on the same thing in the last year. Fine. And one more thing I want to tell you, right? So this is how the shear, strain and deformation behavior looks like in the clays. Now if you observe the टेस्ट फेल्योर, यू नो, सॉइल टेस्ट होने के बाद निकाल के हम लोग देखेंगे तो, सो द फेल्योर विल बी समथिंग लुक्स लाइक दिस, यू नो. सो इन द ओवर कंसोलिडेटेड क्लेस you will see some kind of shearing plane, you know. So this is what we call brittle failure in case of over consolidated clays, so which you are observing here, you know. So this is kind of brittle failure, suddenly increasing and then drops down, right? But in case of OC clays, the failure will be something like this. So ये fail ही नहीं होगा, क्योंकि this is normally consolidated. This will get bulged in the center direction. Load apply कर रहा है तो, so what happens? Volume will be shifting in this direction. You know, this will move in this direction. Center से bulge हो जाएगा. Fail नहीं होगा, bulge हो जाएगा. So that is why you cannot define the failure in normally consolidated clays. तो हम क्या करते हैं कि, so we'll take strain of 20%, so strain of 20%, and we'll define that as the shear strength, you know. Shear strength we define as the strain corresponding to 20% in case of normally consolidated clays. Fine. So this is the behavior of clays in CU टेस्ट. अभी और एक चीज बताना मुझे. सो मैं इधर मोर सर्किल्स ड्रॉ किया था. सो दीज आर ऑल मोर सर्किल्स करस्पॉन्डिंग टू टोटल स्ट्रेस, राइट? आई एम नॉट बॉदरिंग अबाउट व्हाट इज द पोर वाटर प्रेशर मेजर्ड. सो दीज आर ऑल द टोटल स्ट्रेस मोर सर्किल्स. बट इफ आई वांट टू कन्वर्ट दिस इनटू इफेक्टिव स्ट्रेस पैरामीटर्स, तो क्या करना पड़ेगा मुझे? टोटल स्ट्रेस से पोर वाटर प्रेशर निकालना पड़ेगा, है ना. सो आई हैव टू सब्ट्रैक्ट पोर वाटर प्रेशर फ्रॉम टोटल स्ट्रेस. सो वी डू फाइंड आउट द पोर वाटर प्रेशर आल्सो अलोंग विद द टेस्ट अरेंजमेंट्स होता है ट्रायक्सियल सेल सेटअप में. पोर वाटर प्रेशर कितना डेवलप हो रहे हर स्टेज पे. सो दैट सेटअप वी हैव, राइट. सो after finding out the pore water pressure, you can find out the effective shear strength parameters. With the help of pore water pressure, we can find out the effective shear strength parameters, something like this. So this is the Mohr circle for the total stress earlier, right? And ऐसे ही और भी Mohr circles रहेगा, मैं ये इधर एक ही दिखाया था. So Mohr circles will be something like this. These are all the total stress Mohr circles, which are all touching this failure envelope. So this is the failure envelope, right? So this is the failure envelope. Here over consolidated clay के लिए. So this is behaving as a over consolidated clay. ये extend करेंगे तो this will touch the origin, because the normally consolidated clays will always pass through the origin. Failure envelope normally consolidated clays will always pass through the origin. Fine. लेकिन मुझे ये this is all the envelope that I got from total stresses, you know, whatever the stress I'm applying, that from that total stresses I'm getting this envelope, right? But I want the envelope corresponding to effective stresses. तो क्या करना पड़ेगा? मेरा सिग्मा 1 है, C1 है इधर. So this is the confining stress. So sigma D1 इधर कहीं पर होगा, right? So the point is, whatever the stress I'm giving in the second stage, sigma D1, so that is converted into pore water pressure, you know. So that is converted into pore water pressure, because this so the thing is, as this is converted into pore water pressure, you subtract the pore water pressure from the cell pressure to get the effective stress, isn't it? So total stress से pore water pressure subtract करेंगे तो तब हमको effective stress मिलता है. So this is the effective stress, this is the total stress. So this is sigma dash C1, so which is equals to sigma C1 minus pore water pressure develop, right? So ये जितना shift हो रहा है, this is UF, that is the pore water pressure, ये point भी उतना ही shift होगा यहाँ तक, you know. So the more the diameter of the Mohr circle is same, you know, the Mohr circle diameter is same, but the Mohr circle shifts towards left in effective stress parameters, right? So because of the subtraction of UF. So if you all Mohr circles shifts left, then you draw common tangent. This is the common tangent that you observe for effective stress parameters. क्योंकि इधर effective stress parameters ले लिया था, तो phi value will be phi dash. So we represent phi dash because the shear strength is governed by C dash plus, if you are using sigma dash, then this will be tan of phi dash. Phi dash is different than phi u. So if you are using total stress here, this equation becomes sigma into tan phi u. So phi u and cu will adjust according to the stresses, failure conditions, you know, because you're finding out the effective stress, this will be phi dash. And this angle will be phi u. So generally this phi dash will be more than phi u. So if you are finding out the effective stress parameters, phi dash, that will be more than the shear angle, I mean angle of internal friction in case of undrained condition, right? So this is what the observed condition. अभी ये normally consolidated soils के लिए, अभी over consolidated soils देख लेंगे तो, so if you look at the over consolidated soil, this is the over consolidated soil where the sigma c is lesser than the confining pressure, तब over consolidated जैसे behave होगा उस केस में. So this is the total stress circle. This is the this dotted line is the total stress circle. So this dotted line is the failure envelope for total stress. लेकिन इधर क्या हो रहा है? Your pore water pressure is negative. That is what we said here, right? इधर हम लोग बोल रहे हैं pore water pressure is negative instead of positive in case of OC class, right? So इधर क्या होगा? So this Mohr circle shifts towards right instead of left, you know. So is there, please explain this diagram. Is here negative pore water pressure? Yeah, Jahid. See, generally in the OC class, we observe negative pore water pressure at the end of the test. उसका मतलब क्या कि बाहर वाला पानी है, which is connected to the soil sample, the soil will try to suck that water into the soil, क्योंकि उसका टेंडेंसी है वॉल्यूम इंक्रीज करने के लिए, है ना. तो इधर पॉजिटिव पोर वाटर प्रेशर कब डेवलप होगा? इस सॉइल को प्रेशर दे रहा हूं तो ये सॉइल उसका अंदर पानी है उसको किक आउट करने के लिए सोचते, सो पानी बाहर जाना है, सो बाहर जाने को रास्ता नहीं है तो इधर कुछ भी हो उसका ऊपर प्रेशर डालेगा वो पानी. सो दैट इज व्हाट द पोर वाटर प्रेशर. बट इन ओसी केस व्हाट हैपेंस इज द सॉइल इज ट्राइंग टू इंक्रीज इन इट्स वॉल्यूम, है ना. तो वो इंक्रीज वॉल्यूम करने के लिए बाहर से पानी अंदर लाने के लिए सोचते, सो इट विल ट्राई टू drag down the water from the pipe, which is not happening. So that's why in this pipe itself the negative pore water pressure will develop. So that is the reason why the negative pore water pressure is developing in the OC case. Over consolidated case mein pore water pressure will be negative, whereas in normally consolidated case pore water pressure will be positive. Fine. So pore water pressure will be positive. Yeah. So that is what we are seeing here, because in the OC class pore water pressure is negative. So the क्या होगा? effective stress increase हो जाएगा, negative minus of minus, because UF is negative minus UF. तो ये more effective stress Mohr circle right side shift हो जाएगा instead of left. So the Mohr circle will shift towards right, right? So as it is shifting towards right, the failure envelope will be observed something like this. So the failure envelope will be observed something. इधर देख लेंगे तो, so if you compare this effective stress failure envelope and total stress failure envelope, इधर 5 वैल्यू बढ़ रहा है, देख रहे हो? सो दिस इज द 5 वैल्यू फॉर effective stress, which is increasing, right? Here also it is increasing, but the point is the cohesion value. If you draw, I mean, this is only one more circle which is represented. So you have total stress circles, something like this, which are touching this failure envelope. And if you convert all the total circles into effective stress circles, so you will get effective stress more circles on the right side, you know. Okay, not here. So which are touching the solid line. So all the effective more circles touching the solid line, this line. So all the effective more circles touch this solid line. This is the line to which the solid is touch, right? लेकिन इधर बात ये कि ओवर कंसोलिडेटेड केस में सी डैश वैल्यू है, दैट इज द कोहेजन इंटरसेप्ट ऑन shear stress axis which is lesser than CCU. कोहेजन वैल्यू कम हो जाएगा if you consider the effective stress thing, you know, if you consider the effective stress thing. Yeah, so this is about the CU test. पहले स्टेज में कंसोलेशन करके सेकेंड स्टेज में ड्रेनेज अलो नहीं करेंगे तो, सो इफ यू नॉट अलोइंग द ड्रेनेज इन द सेकेंड स्टेज, दैट इज U, second U, that is undrained, consolidated undrained. Now if you do allow the water flowing in both the stages, drainage is allowed in both the stages, ये drainage allow करने के लिए क्या करना पड़ेगा? So what do? So we apply the deviated stress. So whatever the deviated stress that we are applying here, इधर अप्लाई कर रहे हैं ना deviated stress, ये बहुत slowly अप्लाई करते हैं, very धीरे धीरे से धीमे से अप्लाई करेंगे. We apply the shear stress very slow, so that's why it takes weeks. We said it, right, while you're testing. So this CD test takes so much of time. It takes few weeks, you know, depends on the permeability of a soil, maybe 2 weeks to some 5-6 weeks also, right? एक ही टेस्ट उतना टाइम तक चलेगा. Fine. Rate of shearing is very slow. That's what we are mentioning. Now here the thing is, at every stage your total stress is equals to effective stress. इधर क्या कि हम पानी को जाने दे रहे है ना, so पानी को जाने दे रहे तो, so whatever the stress that you are giving, that is all transferred into water, and water is also moving out. So eventually it will develop the total stress, effective stress only. Whatever the stress that we are giving, that is effective stress only. You don't have to find out the effective stress separately, because pore water pressure at every stage, additional pore water pressure at every stage is 0, you know. So pore water pressure at every stage is 0, at every stage. So directly you can use those parameters to find out the failure envelope, right? So you can use those parameters to find out the failure envelope. Then the failure envelope will be something looks like this. So this is for over consolidated range, and this is for normally consolidated range. So remember that this line is going through the origin. देख रहे हो? So the normally consolidated soils will pass through the origin. इसका मतलब क्या है? What is this meaning? इसका मतलब मुझे बताना. So I have to tell this meaning also. So the point is, एक बात इधर observe करना. At the same normal stress, if you find out the shear strength of soil, normally consolidated clay में इतना shear strength है, लेकिन same stress में normal over consolidated soils में ज़्यादा strength आ रहा है, देख रहे हो? So the shear strength is generally more in over consolidated soils, right? ये same state में normal consolidated हो सकते हैं कि इसी stress stage में हो सकते हैं. ये दोनों का केसेस में क्या फर्क है? That is what we want to see here. So why this curve? Because for this soil, this is the pre-consolidation pressure. If you go lesser than that stress, this soil behaves as an over consolidated soil. That's why this path is followed. That is why this soil is following this path. लेकिन अलग soil ले लेता तो, so in which the confining, pre-consolidation pressure is very less, पहले load किया नहीं हो, लेकिन in that case, if you apply the same sigma c here, वो normally consolidated soil जैसे behave करेगा ना. So for that case, you will observe more circle, something like this, which is touching this, which is touching this, right? So that's why this curve passes through this origin, right? थोड़ा सा पेशेंस अटेंशन रखना पड़ेगा, बहुत मुश्किल है समझने के लिए. We'll try to understand. कुछ भी प्रॉब्लम हो तो बताना. So at any point, if you are not understanding, just let me know. I'll clarify the things. Fine. Is it clear? If it is not still, if you are not still not satisfying, you will feel good after we do problems. That is the usual drill, you know. जो भी समझ में नहीं आ रहे तो एक प्रॉब्लम लेने के बाद, एक्सप्लेन करने के बाद, ये सब चीज उधर हम लोग अप्लाई करेंगे. So while I'm doing the problems, previous year questions, all the concepts will be explained there also. Then the things will be better after that. So no need to feel anything stressed out or like, yeah. So that's the thing. So this is CD test, consolidated test, consolidated drain test. और एक बात इधर मुझे बताना. So the point is, इधर हमको, so this curve, this is what we know. We are not getting this curve directly, right? This is the effective stress curve we are saying. पहले हमको ये कर्व मिलता था, because it is undrained, CU, consolidated undrained. Undrained case में we are finding out the pore water pressure. So we are shifting the total stress thing to effective stress thing. Then we are getting this effective stress path here, right? So this effective stress failure envelope that we are observing here, this is kind of similar to the direct failure envelope that you observe in the CD test, you know. वही तो बात है. So this failure envelope will be matching with this effective stress failure envelope. That is why this is C dash intercept and this is phi dash. These are the effective stress parameters. These are the effective stress parameters. This is phi dash CD, which is also almost equals to phi dash CU. Effective stress parameters for CD and effective stress parameters you will get from CU are also same. And even this parameter, cohesion, C dash CD, cohesion in CD test and cohesion in CU test are almost same. That is the reason why we most of the times we don't do the CD test. Sir, maybe we can go for another class at the end of this chapter. Sure. So Yeki, this is very important. If you want more classes, then I'll anyway take that, right? So no issue. So it's not like time is bound, right? That's why we have been taking 40 hours. और एक क्लास बढ़ जाएगा तो प्रॉब्लम कुछ नहीं होगा, है ना? So the whole point of taking 40 hours, more than 40 hours, is to make everything clear, right? So no issue. So while you're doing questions, if you have any kind of issues, just post it in the group and we'll have discussion on those things which are not understood properly or difficult to understand. I'll take time to explain all those things. Okay? So yeah. So having said that, क्या बोल रहा हूँ मैं? So I'm saying this thing because the parameters that you get, basically हमारा triaxial test का aim क्या है? To find out C and phi parameters, isn't it? लेकिन इधर बात ये कि मेरा C and phi parameters in CU test and CD test, effective stress parameters, are getting close. तो मैं ये CD test क्यों करूँ? So CU test ही करता हूँ ना. So that is the reason why most of the cases we do CU test instead of CD test. क्योंकि CD test के लिए बहुत time लगता है. So you have to allow the drainage. So the drainage takes so much of time, so many weeks. ये second stage, CS stage में drainage allow करने के लिए बहुत time लगता है. तो वो टाइम कट डाउन करने के लिए मैं क्या करूंगा? I'll do CU test instead of CD test. क्योंकि मेरा पैरामीटर्स ऑलमोस्ट सेम है, right? So that is the point here. But some cases, so CD test is required. Where your drainage is very slow in the field, है ना. अभी हमारा कंस्ट्रक्शन कर रहे हैं, if the construction takes some 30 years 40 years, कुछ कुछ कंस्ट्रक्शन तो चलता है ना मॉन्यूमेंट्स जैसे 40-50 years तक, तो वो उतना स्लो कंस्ट्रक्शन चल रहा होता तो उसी टाइम ड्रेनेज हो जाता है. सो दैट विल बी काइंड ऑफ कंसोलिडेटेड ड्रेन केस इन द फील्ड, राइट. उस केसेस के लिए हमको सीडी टेस्ट करना ही पड़ता है, क्योंकि सीडी टेस्ट में थोड़ा सा ज्यादा होता है ड्रेनेज, आई मीन स्ट्रेंथ पैरामीटर्स. So that's what the whole point, right? Whenever you allow the water to go out, soil gets stiffened, strength increased. पानी को बाहर नहीं जाने दे रहे तो strength बढ़ेगा ही नहीं. So that's why the shear strength parameters that we get in CU test will be generally lesser than this drain test, CU test and CD test. Fine. Yeah. Now I want to tell you one more thing here. So this is all about discussion about the clays, right? This is all discussion about the clays. Now if you take sands, so the sands also behave kind of similarly, you know. So this is the stress strain curve. If you do the sands shear strength tests on sands, so the dense sands will behave like this, strength increases and drops down. Loose sands will be increasing, this shear stress will keep on increasing and they will reach the same stress. That's what we call residual stress, right? Residual stress or ultimate shear strength of a soil, है ना. और ये behavior भी same है, you know, this behavior is also same. But the point is, in sands, most of the cases the drainage is very fast, है ना. तो drainage allow ही होगा तो पानी बाहर जाएगा तो वॉल्यूम चेंज होगा. सो इन द क्लेस वी रिप्रेजेंटेड व्हाट, वी रिप्रेजेंटेड पोर वाटर प्रेशर चेंज, बिकॉज द वाटर इज नॉट अलाउड टू गो आउट, सो द पोर वाटर प्रेशर डेवलप हो रहा है. लेकिन इधर वाटर पास चले जा रहा है तो वॉल्यूम चेंज हो रहा है, राइट. सो द वॉल्यूम चेंज इज समथिंग लुक्स लाइक दिस. इन द डेंस सैंड्स द वॉल्यूम विल जस्ट reduce up to this point at a lower strain, but with increase in strain the volume again keep on increasing, you know. So the volume keep on increasing. ये increase क्यों हो रहा है क्योंकि ये already dense है. So इसका ऊपर मतलब इसका volume कम हो भी नहीं सकते, right? So the volume cannot be reduced beyond this. So that's why the volume will keep on increasing in case of dense sands. इसको कहते हैं हम dilation, you know, dilation. So this behavior of increase in volume or the change in negative pore water pressure, development of negative pore water pressure is what we call dilation behavior. Important, dilation. So this beyond this point represents this point, you know. So this is the strain, right? This is also strain. So at this point, ये same graph में इधर draw करूँ तो, so this is the point representing this point, you know. Because of this dilation, the stress is dropping down here. लेकिन loose soil में volume कम ही होगा. Volume will keep on reducing. There is a much scope for volume reduction. That's why the shear stress will keep on increasing, and it will reach a maximum value at large strains. Fine. यही चीज volume change है. If the same thing I have represented in void ratios, this is the void ratio which is observed, you know. So because the volume is reducing, the void ratio also reduces, right, with the volume. So initial void ratio था E1 for loose soil, ज्यादा है. Loose soil मतलब volume ज्यादा है ना, ये void ratio ज्यादा होता है. Dense sand में void ratio is ED. EL stands for loose, ED stands for dense, right? So in both the cases, the volume void ratio will be reaching same value, you know. So if you are doing the test at same confining pressure, sigma C, loose soil में क्या होता है, volume कम होगा और void ratio भी कम होगा, and it will reach a constant void ratio. और अगर ये soil dense भी होता तो So which is having void ratio which is lesser than critical void ratio से इधर void ratio increase होगा, पहले थोड़ा सा कम होगा उसके बाद increase होगा and it will reach critical void ratio, you know. So this E critical void ratio is same for sigma C. अगर दोनों loose soil और dense soil same sigma C पे test करेंगे तो हम, so you'll find out this void ratio as a same value, you know. So you'll find out the void ratio as the same value. This is what your E critical, right? But if I increase the sigma C, E critical value will change, you know. So if I increase sigma C to sigma C1, my critical void ratio value will reduce, you know. So now the soil volume will be reducing this way. Now the soil volume will be reducing this way, you know. I mean, if it is dense sand, the volume is increasing in this way. So the dense sand, the volume increasing in this way, and the loose sand, the volume decreasing in this way, right? So this is the point here. लेकिन इधर और एक चीज है, so हम टेस्ट करने से पहले ही void ratio critical होता तो, so if the void ratio is equals to ECR, before starting the test, तो ये void ratio कभी कम ही नहीं होगा, you know. This void ratio remains same throughout the test. जितना देर तक हम टेस्ट कर रहे हैं उसी टाइम तक ये void ratio इतना ही रहेगा, क्योंकि ECR is equals to, I mean actual void ratio is equals to ECR, right? So actual void ratio is equals to ECR. So for those kind of soils, the volume will not change. When the existing void ratio is equals to critical void ratio corresponding to that sigma C, and you are testing at sigma C, volume कुछ भी change नहीं होगा, volume ऐसे ही चले जाएगा और void ratio भी ऐसे ही चले जाएगा. So this will be constant throughout the test. अगर इस void ratio से ऊपर होता तो, if your soil is having void ratio more than E critical, then that is loose sand. The volume keep on reducing. If your void ratio of the soil is lesser than this C critical, that is dense sand. Then the void ratio keep on increasing this way. Right? ये चीज मैं और एक ग्राफ में बनाऊंगा. So I have to explain the same thing. So using one more graph. So this is the graph, you know, this is the graph. So with the increase of confining pressure, these are all the sigma C values. मैं sigma C बहुत कम रखूंगा तो, so void ratio that I'll attain is this much. But if I give large confining pressure और एक बार recall कर लेते. Confining pressure मतलब the isotropic stress. पहले स्टेज में, कंसोलिडेशन स्टेज में हम लोग स्ट्रेस दे रहे हैं ना, that is your confining pressure, right? So if the sigma C is more, then the volume reduction will be, void ratio attained at the end of the test will be less. So ECR value will be keep on reducing with the increase of sigma C. So sigma C increase hota to ECR value come over. So the same values we have represented here, you know. So this is the ECR value for, let's say this is sigma 1 curve. This curve is the sigma 1 curve. ECR value is this much. This is sigma 2 curve, sigma C2 curve, where sigma C2 is greater than sigma C1. So critical void ratio come hai. So this is sigma C1, this is sigma C2, this is the ECR2, this is ECR1. So these are the curves representing the critical void ratio with the sigmas, right? So now the point is, mera soil idhar hai somewhere. Okay, I'll take my soil. So this is my soil, right? So this is my soil. Now if I can, I'll take this void ratio somewhere. Where should I take? I'll take the void ratio somewhere here, right? This is my void ratio of my soil, right? This is sigma C2 curve, this is sigma C2 curve, and this is sigma C1 curve. This is sigma C1 curve, right? So same soil पर देखो ये कर्व को दिस इज टचिंग हियर, राइट? सो इसका मतलब क्या कि इसका वॉइड रेशियो क्रिटिकल वॉइड रेशियो से कम हो गया, है ना? सो दिस वॉइड रेशियो इज क्रिटिकल वॉइड रेशियो से कम हो गया. सो व्हाट विल हैपन? सो व्हाइल यू आर टेस्टिंग, the soil volume will get increased. So the void ratio will increase from this level to this level. If you are giving sigma C1, you know, lekin same soil with the same void ratio, same soil with the same void ratio, if you are testing under different confining pressure, which is sigma C2, so if you are testing under different confining pressure, which is sigma C2, इस केस में void ratio इस कर्व पे कहाँ लाई हो रहा है? इधर, है ना? So the void ratio is lying here. So the void ratio is lying here, right? So now this case for this sigma C2, ये और consolidated, I mean dense soil नहीं है. This is loose sand only. So that's why the void ratio is reducing from here to here, right? So for if you are testing the soil at sigma C1, the void ratio is increasing because that is the dense sand for that confining pressure. But the same soil, if you are testing under different confining pressure, this is behaving as a loose sand, you know, because the void ratio is reducing. You dekh rahe ho? So this dense and loose sand are relative things, you know. So ये confining pressure का हिसाब से हम लोग define करते हैं, critical void ratio के हिसाब से. It's not like some soil is loose always, some soil is dense always. So we are defining this loose and dense sand with respect to what stress you are giving in the laboratory, what stress you are giving in the triaxial cell. So this is a very tricky thing to understand, you know. What stress you are giving to the soil, that decides whether it is a loose or dense sand, fine? So its behavior depends on critical void ratio. So that is the significance of critical void ratio, right? So critical void ratio ka matlab, it is the void ratio of a soil which show no volume change, under a certain confining pressure, right? So this definition will लिख लेंगे. So we'll write the definition of critical void ratio. Sir, how we define critical void ratio? That's what I'm explaining. So critical void ratio, you can define so many ways. I'll define this way. So critical void ratio, it is void ratio of a soil, attained at the end of shear test, or we'll say triaxial test, at the end of triaxial test, at the end of the triaxial test, under certain confining pressure, fine. So this is how we define critical void ratio. Uska matlab ye ki, so this is related to soil, this is related to confining pressure. Moreover, you know, ये confining pressure से related है critical void ratio. So this critical void ratio is not same for all the confining pressures. हम लोग कितना stress पे load test कर रहे हैं उसका हिसाब से critical void ratio depend होता है. हम लोग stress कम pressure पे कर रहे हैं तो critical void ratio ज्यादा होता है, ज्यादा pressure पे कर रहे हैं तो critical void ratio कम होता है. Critical void ratio का मतलब है कि ये वो soil है, so this is that soil which doesn't give any volume change if that soil is tested under this much of confining pressure, right? Or you can say that this is some soil which is changing in its void ratio, and finally it is attaining the void ratio which is equals to critical void ratio. So finally, it is attaining the void ratio, which is equals to critical void ratio at the end of the test for this sigma c, right? So this is how we can define critical void ratio. Okay. So yeah, so this is about the drainage conditions and all these three conditions which we have mentioned for the three cases. और भी कुछ टेस्ट है, we have to explain. I'll continue this thing in the tomorrow's class, or you want me to finish it off? ठीक है, नेक्स्ट क्लास में ही कर लेंगे, क्यों खींचना. So why to extend this so much? So we'll explain this thing in tomorrow's class. Fine. और कुछ क्वेश्चंस है? Do we have any other questions? Yeah. Okay, we'll end here.